Hey guys, what's up? So today we're going to be looking at multiples for this lecture. And the definition for multiples says a number that may be divided by another number a certain number of times without leaving a remainder. Okay? So basically, and there's an example here, 15, 20, or any multiple of 5, right? So let's look at the multiples of 5 as an example. Okay? So 5, let's look at the multiples for 5. You have 5 times 1, which is 5. You have 5 times 2, which is 10. 5 times 3, which is 15, right? 5 times 4, which is 20, right? And we can go on and on and on and on, right? Now, basically, that's a set of multiples for 5. 5 is a multiple of 5. 10 is a multiple. 15 is also a multiple. 20, 25, 30, 35, 40, and so on, right? And it goes on forever, okay? So pretty much any number that you can multiply by 5 and it doesn't leave a remainder is a multiple of 5, okay? Any product that you get pretty much when you multiply a number by 5, it's a multiple, okay? Now, let me give a better set for this. Let's call F no, not F. Let's use M because F is probably more for the word factor. Let's use M, okay? Let's call the set M, and M is a set of multiples for 5, okay? So it's 5, 10, 15, 20, and so on, all the way to 5k, okay? Where k is an element of the natural number set, okay? So this is pretty much a definition for the multiples of 5. So any number that's in the natural number set, which would be 1, 2, 3, 4, 5, all the way to infinity, right? Any number that's in that natural number set would be appropriate for this set as well, meaning that it would be 5 times every number in here. Cool. And that's pretty much the formal definition for what the multiples of 5 are. Okay. So let's just clear this and look at multiples of 9 instead. Okay, guys. So let's look at multiples of 9, right? The multiples for 9 should be 9 times 1, which is 9, right? 9 times 1, which is 9. 9 times 2, which would give you 18. 9 times 3, which would be 27. 9 times 4, which would be 36, and so on, right? So let's call a set M, which is the multiples for 9, and the set M would be the multiples for 9. And then it would clearly be your 9 times tables, right? Which is 9, 18, 27, 36, 45, right? 45, 54, right? 54, right? 63, 72, 81, and so on, so on. But we can also put the same thing we did for the last one. We can put 9k, okay, all the way to 9k for all the numbers in the natural number set, okay? So it goes on forever and ever, and it includes all the numbers in the natural number set, okay? So you multiply 9 by all these numbers, and it would be the same set as this one here, okay? So multiples are pretty easy. Let's do some examples that they would ask you. All right, guys, so let's look at these 3 examples. Always good to do 3 examples, right? Or more if you can. And it says, state a set of multiples of 10 less than 80. All right. So this one is easy. Let's call it M10, right? And the multiples of 10 less than 80 would be 10, 20, 30, 40, 50, 60, 70, and right, not inclusive of 80. So that's it. All right. Okay, so this is the set. These are the multiples of 10 less than 80. Easy, right? All right, so let's move on to the next one. Okay. So the next one says state the multiples of 9 less than 63. So let's do the same thing. We're going to call the set M9, right? And then we're going to say, we're going to start off with 9, 18, 27, 36, 45, 54, and not inclusive of 63. So great. And these are the multiples of 9 less than 63. Okay. So great. Easy, right? All right. So let's move on to the next one. And the next one says state the set of multiples of 4 between 8 and 36 inclusive. Okay. All right. So let's call this one M4. Okay. Let's call the set M4, which is the set between 8 and 36 inclusive. Let's just call it that, right? And right, we're going to start off with 8, okay? Because 4 is a multiple of 4, but it's between 8 and 36, and we're including 8 and 36. That's what inclusive mean, okay? So it's 8, 12, 16, 20, 24, 28, 32, and we're also going to include 36. Okay. And that's it, guys. Great. So we finished the 3 questions, and we're actually finished with this topic now. I think we can move on. Okay. All right, guys. So that's it. And I'll see you in the next lecture. And remember to do your best, and God will do the rest.